Hi everybody. I just want to go over a couple things, get a little practice, and then let you guys do some work with some quadratic equations and finding lengths inside of circles. That's a pretty good little assignment. Let me show you about this though. I just want to remind you of products that must be equal. When you got a couple of chords intersecting at a circle, say this chord AC and DB intersecting at P, what lengths must be equal? AP times PC, in this case, would be equal to DP times PB. We can talk a lot about the similar triangles that makes that happen, but what you got to remember is part times part will equal part times part. Those are the products that would be equal in that figure. Same kind of thing here. We got similar triangles, and it's really interesting why it works that way, but what do you got to remember for sure? When you have two secants intersecting a circle, the exterior part PQ times the full length PR will in turn equal the exterior part PS times that full length PT. Just something to keep in your head. It's because of similar triangles, but we don't got to show those similar triangles every time. And what if you had a tangent and a secant? Well, same kind of thing. There's interesting similar triangles here, which gives us a proportion, which gives us interesting products. But let me just talk about those products. The exterior part AB of that secant times the full length of that secant AC is equal to the tangent squared. That's my favorite one, AT squared. I've written a few problems that I thought would be pretty good for us to look at here. I didn't print this page for you. I think I'm just going to show you what they look like. With this figure, AE is 9. Let me put that to work. CD is 18, but E, I think that must have been BE right here, huh? BE. BE is 8, I'm sure of it. And here's a trick here. It tells me that CD, all the way from C to D, is 18. I got to break that into some parts. The way to do that is call one of them X. It doesn't really matter which one you call X. I'm going to call that part X. But if the full length of CD is 18 and we call this part X, what will we call that part? And it's got to be 18 without the X. I'm going to call that 18 minus X. And then we just jump in with part times part equals part times part. And let's do that now. That would look like 8 times 9 in either order there is equal to X times 18 minus X. So yeah, we're going to get a quadratic equation coming here. And I got 8 times 9, that's going to be 72 is equal to, as I multiply through these parentheses, I got 18x minus x squared. And I hope you have a little process that you use when you work with quadratics. We want to have a positive squared term. I'm going to take everything to the left-hand side, set it equal to 0. X squared minus 18x plus 72, because it was already on that side, equals 0. Now let's see what we can figure out there. Going to find a way to factor that quadratic. Factors of x squared, x and x. Factors of 72. Going to have to work on that for a minute. It's an abundant number. 9 and 8 are been used, huh? That's how we came up with that length. But I'm going to have to work on that. It could be 36 times 2. But I got to get this thing with an 18. What else could we factor to get that 72 here? The 36 and 2 won't work, but other factors of 72. Start taking that apart. 6 goes in there, it could be 6. And if you took that 6 out and combined it with there, it would be a 12. And 6 times 12 is also 72. Would that work here? And I think it would, huh? If I put a 6 here and a 12 there, it is true that 6 times 12 would give me 72, but can I get that middle term? That's where it's at, huh? Getting that middle term right. And I think I could, because those sum to 72. I know that 72 is positive. Had these both been negative factors, their product would have been that positive 72. The outside give me a negative 12x, and the inside give me a negative 6x, and that combines for the negative 18x. So I'm thinking there's the good factorization. Let's set those factors equal to 0 and see what comes from that. X minus 6 could equal to 0, or x minus 12 could. And so x is either equal to 6 or x is equal to 12. And truth is, I think in this question we don't know which is which. This one could have been 6 and this one would have been 12, or the converse. It could go either way. But those lengths are going to be 6 and 12. When I say find the lengths of CE and ED, you can go by the way it looks. The shorter one could have been the 6 and the longer one could have been the 12. But just report it as 6 and 12 and I'm happy. Same kind of idea here. Let's jump into a couple of secants. AB is 8. DE is 24. But BC, this interior part here, is 6. And what you got to remember is that exterior part times the full length is equal to the exterior part times the full length. I'm going to call that exterior part X right there. And see about exterior part 8 times full length 14 would equal exterior part X times full length. X plus 24, huh? That's what that's got to be. If I want to talk about that full length. And there we got 8 times 14 is 80 and 32 is 112 is equal to x squared plus 24x. Let's set it equal to 0, see what comes. Say, dragging everything to the right hand side, I got x squared plus 24x minus 112 equals 0. I'm sure we're going to factor it. Factors of x squared are going to be x and x. We just got to start thinking about that 112. How are the ways I could come up with that 112? And I know that they're going to have a difference of 24. That's what I'm thinking right now. Looking hard for the factors of 112. 2 goes into it 56 times. But I can't make that work here. And if I take another 2 out of that 56, it'd be 4 times 28. Will that work here? And use that 4 and that 28 to get a... They do multiply to give me 112, but can you get that 24 out of that? And I'm thinking that you could. I'll try that. Go with a 4 here and a 28 there. I know 4 times 28 is 112, but I got to get a negative 112. So, since the middle term is positive, the 28 would have to have been positive, and the 4 would have been negative. And we ought to check that factorization. First times first gives me x squared outside positive 28x, inside a negative 4x. There's the 24x we wanted. Last time's last, the negative 112. Hey, set those factors equal to 0. X minus 4 could have equaled to 0, or x plus 28 could. So x is either equal to 4, or x is equal to negative 28. Now that erroneous root is interesting to me. This has happened before. But had this length been 4, which is I think the proper answer, then this full length is 28, isn't it? I just think that's kind of reflected in this erroneous root. But what was asked of me? Find length AD, and AD is 4. I'm happy to have that. One more time here, let's take a look at this one with a tangent and a secant. AT is tangent, AT is length 8. BC, the interior part of the secant, is 12. Find that exterior part. Let's just call it x until we figure that out. How's this go? The exterior part, x, times the full length of the secant, x plus 12, must equal the tangent squared. There's the good-looking equation. Now let's just take care of business, see what we can do with it. I get x squared multiplying through those parentheses plus 12x equals 64. Going to drag it all to one side, going to set it equal to 0. That's what you do with quadratics every time. X squared plus 12x, if you want to solve a minus 64, equals 0. Again, this wouldn't be factored nicely. I'm thinking that it could. Factors of x squared are x and x. Looking for the factors of 64. Could be 32 and 2. But that won't do that 12. Could be 16 and 4. And that'll do that 12, huh? Start taking apart that last term. 16 and 4 works pretty nice, huh? With a 16 here and a 4 there. That 16 times that 4's got to be a negative 64. One of them's got to be negative. The middle term is positive. So I would like this product, 16 and x, to be a positive. and this product, the 4 and the x, to be negative. That way I get a proper middle term of 12x. You check that factorization, looks good to me. Set those factors equal to 0. X plus 16 could equal to 0, or x minus 4 could. So either x is equal to 4 or x is equal to negative 16. I'm thinking x is 4. So with that length being 4 right there, that's all I really wanted, find the length of AB, and we got that. But how about this full length? Isn't that interesting that the full length from there to there, from A to C, of that secant segment would have been 16? I think that erroneous root, it kind of plays there. I want to show you something that usually comes into play when we get around this section in a fine geometry class like yours. Really similar questions here. And kids came to arguments about these, but I'm really thinking there's nothing to argue about. Let me show you what I mean. This is tangent to this circle C, and this is the center of the circle. Compute the radius, it tells me, and AT is 12. And AB, this exterior part there, is 8. And you might have a ticket for this one. I'm thinking we practiced this before. I could call this R and call this R. Recognize there's a right angle here and hit it with the Pythagorean theorem, and that would be all sound judgment. Let's do that for a second, see what that does. R squared plus 12 squared ought to equal that hypotenuse. Now, how long is that hypotenuse anyway, huh? 8 plus R, quantity squared. We're going to need to square that carefully, aren't we? R squared plus 144 is equal to 64 plus 16R plus R squared. Yeah. Well, let's multiply 8 plus R times 8 plus R. Because that's how you get 8 plus R squared. And 8 times 8 is going to give me 64. Outside terms give me 8R, and the inside terms give me 8R. That's where I got 16R. And the last one times the last one gives me R squared. And just sorting through the things we know here. Hey, I got R squared on both sides of this equation. Drop them off on the corner like stepchildren. We don't need them. Didn't mean it. Love stepchildren. I'm a stepchild myself, but that's not what we're here to talk about. 144 equals 64 plus 16R. Subtract 64 from both sides, then I got 80 equal to 16R. Divide both sides by 16. That made me think that the radius is equal to 5. Yeah, I bet you've agreed with me. But now, real similar situation here. This AT is 12, and AB is still 8. But remember this idea that the tangent squared equals the exterior part times the full thing? Shouldn't that work? Instead of using the Pythagorean theorem? Let's see what happens when we try that. Because we're working questions just like that a moment ago. Tangent squared equals exterior part times full thing. Let's call this interior part here D for diameter, could we? And the tangent squared should equal the exterior part, 8, times the full length, and that would be 8 plus D, huh? Let's see what that brings us. 12 squared is 144 equals 64 plus 8D. Multiplying through those parentheses, subtract 64 from both sides, and we got 80 is equal to 8D. Divide both sides by 8, and I'm thinking that the diameter must have been 10. Does that argue about with what we found up here? No, I'm thinking it's perfectly valid, huh? These things go jive well together if the diameter's 10 and the radius is 5. But these are completely different ways to work this question. And I think it's beautiful that they give me the same answer. I kind of expected that they would.